All right, today I'm going to continue on and teach you how to balance in basic solution. So everything we've learned up to this point in balancing half reactions has been about acidic solution. So when you've got basic solution, you're going to do exactly everything exactly the same as you did for acidic, but we're going to add another step. So let me complete this problem for you first, duplicating the steps for acidic, and then continuing on because it's actually in basic solution. So if you remember, we decided that iodine went from -1 to 0. Its charge went up. Therefore, it gained electrons. Lost electrons and was oxidized. And then chlorine's charge went down, so it was reduced. It gained electrons and was reduced. So I'm going to split them into half reactions. Like such. So first thing I'll do is balance everything but hydrogen and oxygen. Next thing I do is add water to balance oxygen. And then I add H pluses to balance hydrogen, like such. So now both of these are balanced according to mass, and we have to accommodate for the charge. So remember, this one has a charge of -2 on the reactant side right now. So I have to bring the product side down to -2 by adding 2 electrons. We count up 2 pluses here and 1 minus, so we have a total on the reactant side of +1 as a charge. On the product side, we have -1. So we'll bring the reactants down to -1 with 2 electrons. So I'm going to add this up like such. If this was an acidic solution, we would be done, but we're going to continue on and do the product reaction in basic solution. So when we do it in basic solution, what you're saying is, I don't actually have H+. These H pluses here are not present in basic solution. Basic solution means OH minuses. H plus means acidic solution. So I'm going to add hydroxides to each side. What that's going to do is it's going to take the H pluses and turn them into waters. So anytime an OH minus comes in contact with an H plus, you're going to be left with water. And that is how we account for the fact that we have no H pluses. So let me go through with this. 2I minus plus OCl minus let's double check that the charges still add up and that the law of conservation of matter, that the mass still adds up. So I have 2 times 2, 4 H pluses over here, 2 plus 2, 4 H's over there. So 2, 3 oxygens, 1, 2, 3 oxygens, 2 iodines, 1 chlorine, 1 chlorine. So we add up. Now we just have to make sure our charges add up. I have 2 iodide ions for -2, -3 on the reactant side, -1, -3 on the product side. So we're all good. The only last step we have to do is cancel the fact that we don't need water in the reactants and the products. So if I have 1 water in the products and 2 waters in the reactants, what actually ends up happening is one of these waters cancels one of these waters. So my final answer becomes as such. And I double check because I'm in basic solution. I can't have H plus, that's acidic solution. I can have OH minus because that's what it means to be basic. And this would be your final answer. So up until we added these OHs in this step right here, remember you add OH to one side, you have to have OH to the other side. Up until that point, it was the same as acidic. From this point right here until the end of the problem is how we account for the fact that it is basic. And that's how you balance half reactions with the half reaction method in basic solution.